Yeah, you want to torque it though?
Oh, we got it tight.
The goal of the El Nino Rapid Response Experiment is to look at how changes in the weather patterns, the evaporation of moisture in the tropics, how that has changed during a major El Nino event like the current one out there, and then to look at how those changes further impact the weather on the west coast of the United States. My name is Gary Wick. I'm a physicist with the NOAA Earth System Research Laboratory Physical Sciences Division in Boulder, and I'm on assignment to the Unmanned Aircraft Systems program within NOAA.
Boy, that was the easiest we ever did it.
During this campaign, we have 4 instruments on board the Global Hawk aircraft. The first is a dropson system, which it deploys these very small sensors, much like weather balloons that go up, but these go down. So these small sensors, they're about the size of a paper towel roll, and as they fall, they collect very high resolution, vertical resolution measurements of temperature, humidity, and wind speed. So they give us a very detailed picture of the atmosphere.
Ready, Mike? Yeah.
In addition to that, we have the HAMSR, which is a microwave sounding instrument, and that provides sampling much like one of the weather satellites that is used extensively in our weather models. The third instrument is HIRAP. It's a Doppler precipitation radar. So just like the weather radars on the ground, we're flying a radar on the aircraft which gives 3-dimensional coverage of precipitation, of rain droplets, and with information from those rain droplets, we can derive continuous measurements of the wind speed in the atmosphere. The final instrument is the NOAA ozone sensor, which provides measurements of ozone concentration at the flight level of the Global Hawk. The Global Hawk provides amazing capability for this experiment just in its ability to be airborne for up to 24 hours or more. That by being aloft for that long, we can sample a large range of the ocean, almost like a satellite does. That with the Global Hawk, we get very detailed sampling like an aircraft, but with the endurance that a satellite would give us. So we're able to sample this large area and look at changes in the atmosphere that wouldn't be possible with other traditional manned aircraft.
My name is John Newhouse. I'm a Deputy Project Manager for the NASA Global Hawk program. I'm actually a commissioned officer with the NOAA Commission Corps. I've been flying the Global Hawk here at NASA for 4 years as an aircraft commander and instructor pilot. So as you can see here, the Global Hawk has no yoke or stick to fly with. We use a mouse from takeoff to landing, climb and descents when we're underway. Everything is automated in the Global Hawk. So all I need to do is do a mouse click here on the screen to say takeoff or to land, climb, descent, maintain an altitude. Everything is done by this mouse click. And it's very much like flying an autopilot in a manned airplane. And what NOAA is using this is as a study to use unmanned aerial vehicles over high-impact weather events such as hurricanes, and in this campaign we're actually using it over El Nino events in the Pacific. We're going to be working with Air Force C-130s, we're going to be working with NOAA Gulfstreams, and also a NOAA ship, the Ronald H. Brown. So we've got C-130s covering one part, G4 covering another part, the ship covering other stuff, and then we're going to be in the parts that are harder to reach.
We typically take off at first light so we can get to the area of interest to study El Nino weather per the science requests. This usually takes about maybe 8 hours to transit to the area that we're studying. And once we're there, we spend several hours analyzing all kinds of weather phenomena that has piqued the interest of the scientists. And it usually takes about 8 hours to bring the plane back home. So that gives us about a total flight time of 24 hours for each sortie. I'm Herman Posada, and I'm a UAS research pilot here at NASA Armstrong Flight Research Center, and I fly the Global Hawk for airborne science. While we're flying the aircraft, we're monitoring many screens. Mostly we're looking that we're on the right track that science has requested us to fly on. We are also obviously looking at various parameters of the aircraft, make sure we don't get any trouble with airspeed, altitude, or the heading. The flight plans continuously getting updated as science changes the area of interest. Obviously, these storms are moving, and we are trying to keep up with them.
Mission pilot.
So in the Global Hawk Operations Center during a flight, we're going to be monitoring the flight with this wonderful mission tool suite capability that NASA has developed. And with that, it allows us to see the data coming in from the aircraft in real time, satellite data, and multiple things for us to really see what's happening as we go along. And so what we'll be watching for is, can we see the weather patterns? Can we see patterns in the humidity that let us know that we're sampling the areas that are eventually going to move downstream and impact the U.S.? The Global Hawk is a one-of-a-kind capability that, NOAA, we have a great observing system from satellites to aircraft to ships, but there's nothing that provides the capability of the Global Hawk. So within NOAA, we really want to see if that is a really good addition to our current observing system. And so by collaborating with NASA, we get this wonderful opportunity to test its capabilities, see its impact on the forecasts, and then hopefully that opens the door for a broader collaboration down the line to do this on a regular basis.
Copy, and release will be in any right turn away from you.
This is a lab, measuring instrumentation, probes, sensors, gas and liquid chemicals, computers. Yeah, this is a lab, but maybe not the lab you would expect. Meet the NASA DC-8 Airborne Laboratory.
The airplane is designed for different instrumentation suites depending on the missions that we fly. So we have multiple zenith ports that look up, we have multiple nadir ports that look down, and of course many of the window blanks there.
There are 25 instruments on board the aircraft, not only from NASA, but from many universities and other government labs and organizations. And together they paint a picture of the atmosphere that can allow us to completely evaluate what emission sources in the peninsula are contributing to poor air quality and how the chemistry actually works in terms of the outcome at the end of the day when ozone and particles are such a concern.
Yeah, this integration is about as big as we do, and if you've seen on board the airplane, you can see it's very full with all the racks and most of the windows, covered with the in situ probes that are there.
The CHORUS AQ campaign will gather air quality data in and around the Korean Peninsula from multiple sources, such as ground stations and maritime sensors. However, the CHORUS AQ aircraft will be the ones to provide the most detailed information over a larger geographical area and at different altitudes.
So in order to understand how it all works, we have several aircraft that we have to fly. One is the one I'm standing on right now, the NASA DC-8. The DC-8's role is to measure the atmosphere directly. From this aircraft, we can measure literally over 100 different compounds in the atmosphere.
The airplane flies as easily at 500 feet as it does at higher altitudes. That enables us to do both remote sensing, which is using radars or LiDARs, as well as we can fly lower, we can do vertical profiles with our in situ sensors, which is currently what we got mostly on this airplane.
In order to understand the atmosphere, there are many different molecules that we have to measure. The satellite will not see all of them. And so by being able to measure what the satellite will see and at the same time see all of the details, we can begin to understand what sources and what meteorologies and what combinations of conditions will affect what we see from space.
By combining detailed measurements from aircraft with those made by satellites, we can get a better picture of pollutants in our atmosphere.
So this aircraft carries instruments that work just like the satellite instruments. The higher we fly, the wider the patch of Earth we can see.
During the campaign, NASA King Air aircraft will mimic the measurements future satellites will make.
We fly at about 28,000 feet, and at that altitude, we see about a 5-mile wide patch of ground. Like mowing the grass, we're just trying to cover a patch on the ground continuously and make a map of what the pollutant distribution looks like.
So we have a small King Air aircraft flying above all throughout the day, measuring the way the future satellite will measure air quality. Meanwhile, the DC-8 flies underneath, showing what the distribution of pollution is above the ground. That allows us to understand how to connect what the satellite sees with what's at ground level.
Chorus AQ has in its team 2 smaller aircraft equipped with atmospheric chemistry measuring instrumentation. A King Air from NASA Langley Research Center, and a King Air provided to the Korean National Institute for Environmental Research by Hanseo University.
The Hanseo King Air is relatively smaller than DC-8 in NASA. It can freely access source of pollution and measure air quality capital territory that cannot approach using DC-8.
Working all together, scientists from the Chorus AQ campaign will provide valuable data and test the technologies needed to better understand air quality and the flow of pollutants within our atmosphere.
We can only fly the planes for a very short period, but the details that you get from the aircraft help inform the observations from space and from the ground, and how models can interpret those observations.
From this mission, we'll have better models and better mission data for Asia, and so we'll be able to extend the usefulness of this well beyond South Korea to other developing cities around the world.
We have the tools to study our atmosphere. Now, let's go exploring. Get to work at 5 o'clock. Morning briefing at 6:30. It's just another day at the office. Or is it really?
There's a lot to juggle in the field, so life in the field can be quite hectic. It takes 3 hours to do a full warm-up of all the instruments on this aircraft. That means a start at 5 a.m. in the morning and a takeoff at about 8 a.m. The forecasters will look at the conditions to verify that the flight is ready to go, and the plane will take off for an 8-hour flight.
So, if you're a scientist studying air pollution, where should you be doing your research? Yep, that's right, in the air.
Once the plane takes off, the fun begins. There's a lot of talk on the headsets about what we're seeing and whether it makes sense in terms of what the models had predicted. Don't forget that this aircraft is flying in the atmosphere to verify whether the models can do a good job of predicting air quality. Each flight begins with a pass through the city of Seoul for a chance to see what that looks like. And then we go to high altitude to fly along the peninsula, along a route that we've chosen, and looking down with what we call the LiDAR. The lasers that point underneath the aircraft provide information on the pollution levels at different altitudes down toward the ground. And we have to use that information to decide where we will want to sample in altitude along that same path following the LiDAR path. That 8-hour flight does not stop us from continuing forecasting on the ground and trying to give information to the flight as it happens in case conditions change. And so those days can be very busy between planning tomorrow's flight but making sure that today's flight happens well.
There's a lot to do on the flight days for the scientists on board the aircraft. However, there are other teams that also have to be working around the clock in order to have these airborne laboratories ready for investigating the atmosphere.
On this mission, the maintenance crew is pretty busy. We've got so many scientists on board. All the scientists have different needs and requirements, such as changing out some of the gases they have on the airplane. They also need to definitely make sure the airplane is pre-flight right, so we're good to go. Check out a lot of the systems. They're refueling the airplane. Before the flight, they take off all those covers off all the probes, which actually takes quite a bit of time. And then after the flight, they need to put those back in place. So, I mean, the maintenance crews are the guys. They're the first guys to show up in the morning and the last guys to leave at the end of the day. They make sure we have a good jet for that day's mission. And if we break the jet on that mission, they're the ones who've got to fix it and get it ready for the next one.
Teamwork is the key to a successful campaign. The Chorus AQ mission involves the coordinated effort of over 500 people.
We have about 505 people registered on the mission website. Of those, about 300 have been active participants at some point during the deployment, and we had to ensure that everybody had access when they needed.
Scientists, crew, technicians, but also equipment, supplies, logistics. A massive scientific research mission requires planning ahead and effective management.
Preparations for something of this size begin years in advance. And so, having already visited here with the Earth Science Project Office several times, we were able to put together a situation that would enable this many scientists and this many resources to be put into play.
It's was involved in all phases of the mission, from its conception to its planning and the implementation. We need to understand what the researchers want, which become our requirements, and then we come here and see how we can best meet those requirements, whether they are logistical or operations.
The Earth Science Project Office is in charge of managing the mission. Anything you need to accomplish your objectives during the mission, they are the people to go to.
Entering a foreign country is very difficult with all the things that we bring. Operating in a foreign country is difficult because their airspace is very busy and maybe some of their procedures are different than ours. And keeping the flow of people and information and equipment smooth and in a way that does not interrupt or distract us from the science is a great talent, and we appreciate the Earth Science Project Office's support.
They are the ones making sure scientists have everything they need to keep working every day. So if you want to do a good job, you have to go to the right place and measure at the right time with the right people. And for these people, the right place is in the air. Although in the end, for them, maybe it wasn't just like another day at the office.
Yeah, it's a totally different experience.
The work we do here day to day is much different than what we do in the lab.
I've been waking up pretty early at about 4 a.m. and then we get out here at about 5 to warm up our instrument because the laser takes a while to warm up to peak power.
We'll be taking out gas cylinders and putting in new ones.
After every flight, we switch out the air canisters for the next day's flight.
Filling water or calibrating the instruments, making sure they're running correctly.
And then we come back out and mess with the laser a little more. So I've definitely developed my muscle mass here.
You know, it's a lot of work, but it's also a lot of fun. And, definitely different from just working in a lab or in an office all the time.
for the first time in my life, I saw the horizon as a curved line. It was accentuated by a thin seam of dark blue light, the atmosphere. This was not the ocean of air I had been told it was. I was terrified by its fragile appearance. In 1983, German astronaut Ulf Mervold, on board NASA's space shuttle, was struck by how vulnerable the layer that protects us from outer space really was. He was right. Industrialization and economic growth have given us many commodities and technologies, but they have also generated a dangerous side effect: pollution.
Air pollution has a great impact on human health.
More than 7 million people die per year due to the effects of air quality.
It's a big problem. Populations are growing, and the impacts on health are an economic cost that governments are very interested in.
Understanding how we are affecting our atmosphere and the quality of the air we breathe is essential not just to continue developing our societies, but also to our health and therefore our survival. By combining measurements from satellites, ground stations, and aircraft over the South Korean peninsula, CORUS AQ will create the most complete picture of air quality ever measured.
As atmospheric chemists, we do know a lot about the basics of air quality, but the specifics of what happens in Korea are not something that we know a lot about.
It's not a mystery to us that there's a lot of air pollution. What we're really trying to do is learn how we can best help the South Koreans improve their air quality.
Government is trying to come up with a better strategy to fix this issue, but it's not that easy. You know, it's very complicated scientific issues we are facing. So I think this mission really helps us to understand what is going on in our country.
But air pollution is also an environmental problem common to other cities in many countries.
It turns out that there's many cities around the world that have similar problems to Seoul, even in the United States. And so this field study will help improve the models and the processes in the models that will benefit many other cities around the world.
The information gathered throughout the CORUS AQ campaign will help us improve our models of air quality and better understand the flow and interaction of pollutants in our atmosphere.
Almost anyone who you tell about the CORUS AQ experiment will immediately ask about how much of it's coming from China. Transboundary pollution is always a concern, and we came here to look at that as well. But we've had the good fortune of having a weather condition that has created a lot of stagnation in the Korean country and has prevented Chinese emissions from having a large impact on Korea.
Yeah, we sort of expected that frequently there would be pollution from China blowing over Korea. But due to the meteorological conditions this year, that didn't seem to happen very much.
It turns out on some days, the emissions from China is impacting South Korea, but on many days that we're here, it's entirely due to the pollution emitted by the 51 million people living in South Korea.
And what we believe is that this will motivate the Koreans to understand that they can make a difference in their own air quality by making local changes of things that they can control rather than worrying only about what's coming from outside.
Having detailed information on the sources causing air pollution is one of the most important outcomes of an air quality study. Decisions can be made in order to address environmental issues on a region.
We have also seen that the position of some emission sources, in particular with Seoul being in the northwest corner of the country, and also many of the power plants and chemical facilities upwind of the city, that the location of some sources is potentially creating a bigger problem in Seoul than is necessary. So looking at the balance of where activities are located in Korea is likely going to be a topic of interest for the outcomes from CORUS.
Real-time measurements of emissions over the Korean Peninsula has already proven the importance of this field study. Further and more detailed analysis of the data collected during the campaign will help scientists improve air quality models.
So now we will have the 6 weeks of data of hundreds of different compounds to evaluate our models with, to see how they do during these 6 weeks. And then if we can make our models reproduce this period, reproduce all the observations we've made, then we can have confidence that it will work well next year or next fall.
These models also help us test how we can best reduce the air pollution by what if we cleaned up the cars, how much would that help? What if we cleaned up the power plants, how much would that lower air pollution? So these models are useful tools to look at different scenarios.
It's relatively simple to filter out or scrub emissions, but it's not inexpensive. So if you know which ones will have the largest impact, then you can target those and still have good economic productivity and protect your population.
Computer models can help assess air pollution problems and guide politicians in the decision-making process to lessen industrial impacts on the environment.
We definitely have tech.
After weeks of hard work and intense data collection, the CORUS AQ field study has enhanced our knowledge of our planet, our understanding of the complex processes that take place in our atmosphere.
With CORUS HQ, we take another step toward the future of an air quality observing system that is going to make us able to be more effective in identifying where poor air quality is developing and how to better understand what's driving it.
Because I think the air pollution issues is not only for us, but also from some other countries.
We are paving the way to better understand pollution and our impact on air quality in our atmosphere. But there's still much work to do ahead of us.
I think that as we reach 7 billion people on this planet, the consequences of what we do have a very significant impact on the environment. And we need to understand what we're doing very well.
So this is the first step of a long journey. We will still need additional aircraft measurements and ground-based measurements going forward.
We can't be everywhere with the plane. But now that we demonstrate here how the plane works in concert with satellite observations on the ground, we can use satellite observations to point the aircraft to the places where we can learn the most, or the places that are in most need of understanding what's going on.
So we must continue investigating, exploring this world to improve the lives of all of us who call this planet home.
When you put a human being in a spacesuit, suddenly the impossible is possible. Since 1965, NASA has conducted hundreds of EVAs, short for extravehicular activity.
So when I think of EVA, I think of the symbolism of a fellow human being existing for even just a short period of time, alone and separated from nearly everything else. And I think of that symbol of that single person representing our species and representing our voyage of exploration.
Before exploration can take place, before a human being can step outside the spacecraft, another mission must be accomplished: the creation of the spacesuit. Throughout the history of EVA, NASA has sought to build the best spacesuit and tools to match the job required for the mission. For our suit engineers, this means designing, testing, and redesigning to get it right. During Gemini, our designers were faced with a tough challenge to create the very first U.S. spacesuits. Suits that would allow astronauts to work outside the spacecraft in low Earth orbit. Building on that experience, new suits were developed for the Apollo missions. This time, astronauts needed to walk on the moon while carrying their own life support on their backs. With planetary surface exploration as the objective, the suit had to bend and move to facilitate tool use and protect the human. During the shuttle years, NASA redefined what could be done with EVA suits and tools, retrieving broken satellites, rescuing and rebuilding the Hubble Space Telescope, and building the International Space Station. The same shuttle spacesuit is on the space station today. It allows us to maintain and repair our home in space. But what about future missions? What kind of a suit will we need? Will we be walking on a planetary surface? Floating in microgravity? Or both? NASA is already investigating the next generation of spacesuits, creating a variety of prototypes to prepare astronauts for the journeys ahead. The Z2 is one of those prototypes. Its sleek design looks different from any other spacesuit NASA previously built.
We were able to take some artistic license on this prototype spacesuit and have some fun with it and engage folks out around the country for what they would like to see in a spacesuit. We work with Philadelphia University to do the initial layouts of the suit, and then we have some in-house fashion designers that also help build our spacesuits, and they were able to bring their experiences to it and evolve that cover layer to make it even better than what we started with.
The Z2 isn't just fashion forward on the outside, it's also technologically advanced on the inside. This is one suit made for walking, on other planets that is.
To be a planetary spacesuit, some of the special features on the Z2 are boots specifically designed for walking and for keeping your foot integrated into the boot well, like a good hiking boot. It also has a lot of lower torso mobility that allows you to walk naturally so that you can go uphill, downhill, into craters, pick up a rock, as a geologist would want to do on a planetary surface.
Like any prototype, NASA hopes to learn a lot from the Z2 as it continues to improve and develop spacesuits.
Prototypes are really important for spacesuit development because you can only do so much in the modeling and analysis world. You really don't know how well the suit works until you integrate it with a person. You get the feedback that person can give you. You have them walk around, you have them try different tasks. That's how we really know that we've done a good job designing a spacesuit.
Another suit in the works is the Prototype Exploration Suit, or PXS. This suit could be used for EVAs in microgravity, or it could be further modified for walking on planets. As with all future spacesuits, NASA is wanting to see better mobility, more visibility, and better control and communication.
So one of my main responsibilities on this spacesuit is the suit control assembly, and that's the box that sits right here on the front of the suit. And it allows the crew member to control their life support components, such as their cooling and their pressure, and it also controls a lot of the electronics, such as the radio and the volume, and they can see some of the data that's coming back and forth from the suit computer to that display. So one of the great things about this job is that after designing the box, I'm able to get into the suit, since it's one of the smaller sizes, and we can actually see what the limitations are, with my own hands and eyes, and not just hear that secondhand from another test subject that would be looking at the same data. And then to take that back and then to go build the next prototype and incorporate changes that need to be made so that it works better the next time.
Whether it's the PXS or the Z2, new NASA spacesuits have a big job to do.
And that's not just being in a vacuum, but it's very hot, it can be very cold. And then in addition to that, there are little micrometeoroids that are flying past that you have to protect in case it does hit the suit. So there's a lot of things that go into protecting the crew member in addition to just being in a vacuum. And when we go farther to the moon or Mars, you have to protect in case you trip and fall. So there's a lot of protection that the suit has to take into account.
No matter where we go or what we do, spacesuits and EVA tasks will continue to change and evolve. To keep up, spacesuit engineers will use new technologies, new materials, and new ideas to help us on our way.
In the future, I'm looking forward to spacesuits that are much more of a tool for the astronaut, that is more integrated with the human, and is less of an encumbrance and more of a help.
I think of EVA as basically a ship of exploration, a ship of learning and understanding, both about what makes us individually human and about what makes us together a team that seeks to learn and understand what the truth around us is. And that search for knowledge, that search for truth is, I think, one of the most noble and meaningful endeavors that we can pursue together.
This is a story about heat. Heat in our atmosphere, our oceans, and land. When you think about it, events like droughts, hurricanes, and fires, all of those are just different ways we see heat expressed throughout the Earth's system. You've probably been bombarded with a lot of intense headlines in 2020. Hottest temperature recorded here, largest wildfires there. It's been a lot to take in. My name is Leslie Ott, and I'm a research meteorologist at NASA's Goddard Space Flight Center. So the reality is the stage was set many years ago for these events. Over the last century, human activities have increased the concentration of greenhouse gases in our atmosphere. These gases act like a blanket, trapping heat and leading to overall warming of the planet. Many of these gases remain in the atmosphere for a long time, meaning that we'll be feeling the consequences of this trapped heat for many years to come. Which unfortunately means next year is probably going to bring a lot of the same kinds of stories that we saw in 2020. But taking a look at all the different ways our planet responds to the variations in movement of heat can help us better prepare for the future. Maybe one of the most obvious ways that we saw heat this year was through fire. I know the Australian bushfires were big news last January, and when you think about it, years of prolonged hot temperatures and drought really set the stage for these fires to be more likely and more severe. With drought and heat waves, we typically see an increase in the availability of dry fuels, which leads to more powerful fires. So when you have multiple years of intense heat, it's not surprising to have significant fire events like we saw in Australia. These fires were so extreme that we saw smoke injected as high as 18 miles above the surface. That's really important because when smoke is injected that high, it can have the same type of effect as a volcano, having these very, very broad impacts across whole hemispheres of the planet. At NASA, we use computer models like the Goddard Earth Observing System to help us study how aerosols and particulate matter move through the atmosphere. So we take these models, we input real-world observations and data to track fire emissions to help understand how they're forming, where they're going, and how much of an impact they'll have on you and me. In California, heat waves have increased fire risk, and as a result, we saw a lot of synchronized fire activity. That is, many dangerous wildfires burning at the same time. And unfortunately, these types of huge fire events are becoming more and more common across the western United States. And that's a big problem. This year, Siberia also had a remarkable and active fire season. What we saw was that temperatures in the region were much higher than normal for this time of year. In fact, the temperatures above the Arctic Circle broke records in many of the same regions where the fires were burning actively. In the Arctic and boreal forest ecosystems, heat waves can exacerbate fires. And in the Arctic, you also have to factor in permafrost, which is soil that's frozen for long periods of time, and that can make the impact of fires in high latitudes even more complex. When severe fires burn in areas with permafrost, we lose this important insulating organic soil layer, which accelerates thawing, and it's potentially releasing carbon that's been stored in the soil for hundreds and in some cases even thousands of years. And you sometimes see these zombie fires, which happen when wildfires burn deep into peatlands or smolder in forests under snowfall. If that temperature doesn't get cold enough to extinguish the fire, they can continue to burn over the winter, even long after the visible fire's been extinguished at the surface. So come spring, they reemerge and they continue to burn back on the surface again. Studying what happens in the Arctic is really important because it's warming about 3 times faster than the rest of the planet. And all those aerosols and the carbon that come out of the Arctic don't necessarily stay there. They affect the heating and air pollution in much larger regions of the planet. Another part of the planet affected by heat, of course, is ice. Land ice in the form of ice sheets and glaciers where we've seen significant melt in recent decades, and frozen ocean water, or sea ice. This year, the Arctic sea ice minimum almost reached a new record low. It was second only to 2012's extent, which was an anomalously low year in part due to unusual weather conditions. Sea ice shrinks and grows with the seasons. After reaching an annual minimum extent in September, Arctic sea ice begins to grow again as sea temperatures cool off for the winter. This year, Arctic sea ice had an unusually slow start to the regrowth period. In particular, the Laptev Sea, which is sometimes called the sea ice nursery because much of the Arctic sea ice initially formed there, was too warm for meaningful sea ice growth until much later in the season than usual. Oceans absorb heat from the sun, and our atmosphere prevents this heat from escaping back to space. The movement of this heat is one of the primary drivers of circulation and global weather patterns. We can measure the temperature of the ocean, and what we saw this year was unusually high surface temperatures across the Atlantic. The warm moisture that comes off the ocean acts as fuel to storms. So as this layer of the ocean gets even warmer, we're seeing that storms are becoming more and more intense over time. In fact, 2020 sea surface temperature contributed to an exceptional year in terms of Atlantic hurricanes. We saw 30 named storms, a new record, and 12 of these storms made landfall in the U.S. What's really interesting is that many of these storms intensified really rapidly. Not only are storms intensifying more quickly, but what we're seeing is that they're stalling near coastal regions more often, which is devastating in terms of floods and storm surge. While we're not 100% sure what is causing these storms to stall, it may have to do with climate patterns shifting in response to rising global temperatures. It's always really tough for a scientist to say any particular fire or any particular event was because of climate change. But we're getting to a point where we're starting to see season after season of record-breaking wildfire, season after season of really intense storms, that it becomes much easier to understand that this is likely the result of long-term climate change. In general, more heat means more energy in the Earth's system. So while 2020 was a significant year, it's important to know that this probably wasn't an anomaly of a year. We're likely to experience many similar years as the Earth's climate gets warmer. So while we saw a small dip in emissions this year due to COVID shutdowns, it was pretty short-lived. The vast majority of our greenhouse gas emissions come from things like electricity generation, which were less affected by the shutdowns than emissions from cars and airplanes. But we know that human activities have a powerful impact on our environment. Long-term strategies to curb human-induced climate change would have to focus on implementing cleaner technologies so we can reduce emissions without affecting people's daily lives. So while this is a story about heat, this is also a story about connections. Nothing on our planet happens in a vacuum, and our actions today impact our tomorrow. The choices we make now can make the difference between continued increases in greenhouse gas emissions and 2020 being the year that they peaked.
The president's funding request for NASA, preparing for first flight on another world, and a new crew heads to the space station. A few of the stories to tell you about this week at NASA. Acting NASA Administrator Steve Jurczyk discussed the president's fiscal year 2022 discretionary funding request for NASA. The $24.7 billion funding request
It allows NASA to address the climate change challenge in more significant ways than we've had in the past. It allows us to understand the Earth as a system, from the oceans to the atmosphere.
The request includes funding also related to climate change for programs associated with the first A in NASA's name.
Aeronautics has been charged with developing a more environmentally friendly aviation system. One of them is the X-57 Maxwell Flight Demonstrator. It's going to demonstrate electric aircraft technology, including distributed propulsion.
Other milestones expected under the new funding request include the launch of the James Webb Space Telescope, which will look back in time to the first galaxies in the early universe. The funding request also is a strong show of support for our Artemis program and Moon to Mars exploration approach. The Space Launch System rocket, the Orion spacecraft, gateway in lunar orbit, and a commercial human landing system will land the first woman and first person of color on the surface of the Moon, and are the systems we will use to establish sustainable exploration and research in preparation for the first human missions to Mars. During a pre-flight briefing on April 9th, the team for our Ingenuity Mars helicopter discussed the helicopter's status and what to expect on its first attempt at powered controlled flight on another planet, currently targeted for no earlier than Sunday, April 11th.
We have carefully designed, we have carefully tested on Earth, we have been checking out carefully on Mars up to now, and it's time to attempt the first flight, and we will test, prove, and learn, regardless of what the outcome is.
If Ingenuity flies on April 11th as expected, a live stream confirming the historic first flight is targeted to start around 3:30 a.m. Eastern Daylight Time on April 12th. Ingenuity, a technology demonstration to test powered flight on another world for the first time, arrived at Mars on February 18th with our Perseverance Mars rover. The International Space Station's newest crew, including our Mark Vande Hei, blasted off on April 9th from the Baikonur Cosmodrome in Kazakhstan. A few hours later, Vande Hei, Oleg Novitsky, and Pyotr Dubrov, both of the Russian space agency Roscosmos, were welcomed aboard the station by the crew already on board, including our Kate Rubins and NASA's SpaceX Crew 1 astronauts Michael Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi. April 5th marked a first for commercial spaceflight aboard the International Space Station when the Crew Dragon Resilience spacecraft carrying NASA's SpaceX Crew 1 astronauts autonomously undocked from the forward port of the station's Harmony module and relocated to the space-facing port. The move will enable the extraction of new solar arrays from a SpaceX cargo spacecraft that will arrive after Crew 1 departs. On April 6th, engineers conducted an RS-25 engine test on the A1 test stand at our Stennis Space Center near Bay St. Louis, Mississippi. The full duration test is the second in a scheduled series of 7 tests to provide valuable data for development and production of the engines. 4 RS-25s will help power the agency's Space Launch System rocket on future missions to the Moon, including the Artemis 1 uncrewed flight test targeted for this year that will pave the way for future flights with astronauts to explore the Moon and prepare for missions to Mars. NASA's OSIRIS-REx spacecraft completed a last flyover of asteroid Bennu on April 7th to document surface changes that resulted on the asteroid during the mission's sample collection maneuver last October. It will take until at least April 13th to downlink all of the data from the flyby. A survey of the sample collection site could teach us more about the nature of the surface and subsurface materials and the mechanical properties of the asteroid. OSIRIS-REx is scheduled to return to Earth with the sample material it collected from Bennu in September 2023. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
Juliet Oscar November calling. NO186, Juliet Oscar November calling. NO186, it is 6 Juliet Oscar November. You copy me, Chris? Copy you loud and clear. Okay, I'm going to patch them through. Please, 1 minute.
This is Owen. How has seeing Earth from its orbit affected you, in your frame of reference when moving around the ISS, or in your perspective of humanity as a whole? Over.
Hi, Owen. That's a great question. Seeing Earth from up here, it's a beautiful thing. It's just this peaceful place with no borders there, and you just see this wonderful colors of blues and greens and browns and white clouds and snow-capped mountains. And it really gives you an appreciation for Earth as a spaceship for 7 billion people, just like our spaceship is keeping us alive, and how we need to take care of Earth because it takes care of us. Over.
This is Spencer. What happens if you vomit in the space station? How do you clean it up? Over.
Well, hi, Spencer. Fortunately, we are prepared for vomiting in space, and we bring special bags that if we're feeling the urge to go, we use these bags. Occasionally, on the launch, it can surprise you, and but we have bags in the launch vehicle as well. If you didn't make it in the bag, it would be a real mess, and it would go everywhere. It would take quite a bit of time to clean up. Over.
This is Lucas. How has the COVID-19 pandemic affected you while you're in space? Over.
Hi, Lucas. The pandemic has affected us because it's affecting our families. Our daily life here on the space station is largely the same with or without the pandemic. We are safe and we are executing our job and keeping the space station running and functioning and keeping ourselves healthy with our daily routine. But we're concerned for our friends and family and loved ones because they're in Russia and in the United States having to deal with it just like you are. Over.
This is Allie. What will be your first meal when you get back to Earth? Over.
Hi, Allie. I like to eat, and so I'm looking forward to any food that somebody makes. But one thing we don't have is an oven here, so something that comes out of the oven and you smell those smells and you eat a nice hot meal, that sounds terrific to me. Over.
This is Sawyer. What does it feel like when the rocket lifts off? Over.
Sawyer, when the rocket lifts off, it's this tremendous feeling like somebody's pushing you in your back and shoving you faster and faster and higher to the sky. And there's a few periods of time where our engines change, called staging, and there's some bumpiness and a little bit of shaking in the spacecraft during those periods. But the rest of the 9 minutes is just like a giant force is throwing you into the sky. Over.
This is Jordan. What does the space station smell like? Over.
Jordan, the space station has not too different smells than you'd have in a home down there. We try to keep ourselves clean. We try to keep the space station clean. In fact, tomorrow is Saturday, and that's our cleaning day, and we do our best to keep it neat and tidy. But occasionally there's smells where we have to change fluid. A lot of times that has to do with our bodily functions in the toilet, and they can be smelly there. But for the most part, the space station, to me, it smells just like a normal home. Over.
This is Eric. Was training to be an astronaut harder or easier than training to be a Navy SEAL? Over.
Well, Eric, they were totally different. The training to be a Navy SEAL initially was
very hard for 6 months. Training to be an astronaut or a cosmonaut is a long process, and it takes many years of hard work. So, and it's more academic, more having to do with your brain. In SEAL training, we had some academics, but largely it was a physical thing. So 2 entirely different programs. Over.
This is Owen. What experiment that you've done had the most unexpected results? What was the expected and actual outcome of said experiment? Over.
Wow, Owen, that's a very detailed question. We have lots of experiments going on up here, but one that, when I first arrived, we were growing some plants, and I thought that they would grow more than they did. Over the course of several weeks, they were just a small sprout, which surprised me, because pictures I had never seen growth in space before on my previous missions. So I'm looking forward to trying that again and getting better results. Over.
This is Spencer. How successful is the 3D printer on the station? Over.
Spencer, we have the 3D printer has been here since I think 2015, a few years, and we've printed many parts. We don't have it deployed and active all the time, but when we need to, we can print what we need if it meets the criteria. It's a very effective way of having spare parts in space. Over.
This is Lucas. You're a model rocket building club. Did you ever build model rockets when you were young? Over.
Lucas, I wish I did, but I never had a club or a mentor in my area that was involved with model rockets, so I never really launched a model rocket as a young person, but I think it's great that you guys do. Over.
This is Valerie. What does microgravity feel like on your body? Over.
Allie, microgravity is more a feel of how to move around. Your body, in my opinion, feels kind of the same. Everything you do on Earth with your body, eating, going to the bathroom, sleeping, your hair growing, all that stuff is very normal, I think. But moving around in microgravity is not normal, and it takes some practice to get used to how to do it effectively. Over.
This is Eric. Does the Earth look any clearer or less polluted now compared to when you flew in 2009 and with Canadian Chris Hadfield in 2013? Over.
I actually flew with another Canadian, your Governor General, Julie Payette, in 2009. So this is my first mission in space without a Canadian crewmate. But the Earth does not look any different with our eyes than the previous times. And my crewmate and friend Anatoly has been in space several times, and we both have tried to see any differences, and we can't really tell with our eyes. Over.
This is Sawyer. Do you play any games while you are on the ISS? Over.
Well, Sawyer, we're pretty busy people up here. We have lots of work to do during the day, and by the time nighttime comes around, we just have the energy to eat and clean up from our day and prepare for the next day. Maybe make a phone call or something, or answer an email, but we don't have a lot of time to play any games. Probably the closest thing to a game is seeing how straight you can fly without crashing into a wall and how far you can go like this. Over.
Well, I tell you what, for all the folks on the phone, let's go ahead and give Commander Chris Cassidy and the crew on NA-1SS a big round of applause anyway. Sending my greetings along to all of you in traditional amateur radio terms. 7 threes, best wishes, and thank you for participating in this activity. Thank you, everybody. This is just excellent.
So we are standing in the Quest airlock, which is divided into two parts. We have the equipment lock and we have the crew lock. This equipment lock has a hatch right here that closes, and the crew lock has another hatch. The EMU, or the Extravehicular Mobility Unit, is our spacesuit, and it's divided roughly into two parts. We have the hard upper torso, which is almost like a turtle shell. It's a hard fiberglass shell, and then we also have the lower torso assembly. These spacesuits are our own little spacecraft, and they have everything you need to keep you alive out in space for 7 to 8 hours, maybe even longer, depending on how hard you're working. The only thing that they do not have, and they have radios, it has oxygen, it has carbon dioxide scrubbing, it has temperature control, it has everything you need except for one thing, a restroom. And so when we get ready for our EVA, the first thing we put on in the morning is a diaper, and that's our first layer. Then over the diaper we put on a pair of long johns, and that's to keep our arms and legs from getting scraped up. It also provides a little bit of wicking in case you're getting really hot and sweaty. The next layer is our liquid cooling garment, and the LCVG has little tubes running through it which allow water to circulate inside the LCVG to provide cooling when we're outside working really hard. So we've got the diaper, we got long johns, we got the LCVG, and then we're going to wear our spacesuit. 7 layers from the bladder on the inside, which maintains pressure, and that's a rubberized bladder, all the way out to the white layer on the outside. The crew member inside the spacesuit is also wearing this, what we call a Snoopy cap. It's a communications cap. We have a radio, so we can talk to not only to Houston, but we can talk to people on the space station and to each other. So we wear this communication cap inside the helmet. Also another key component of the EMU, or a spacesuit, is the helmet. You can see the helmet has a gold visor which protects us from the rays of the sun that we can bring down. It's pretty bright out there, and this gold visor helps reflect the rays of the sun so we can actually see and operate in daylight. At nighttime, we can raise this visor up, gives us a clearer view, and additionally we have helmet lights built into the helmet. On top of the helmet, we also have a television camera, so the ground is able to watch us while we work through these TV cameras. The work is really all done with hands, and so our gloves are really our most important piece of equipment in order for us to work outside. And one of the real challenges of a spacewalk is you have this heavy gloved hand, which is inflated, so it wants to stay like it's blown up like a balloon. But we walk by grabbing onto handrails and making our way along the ISS. So every time you move your hand, you're fighting against a balloon that wants to inflate. And then on top of that, all of our equipment is based on using your hands too. So after 6.5, 7 hours of kind of fighting against this glove, it's a really long day, and your hands are probably the thing that are most exhausted after 7 hours out on an EVA. Well, we're going out to work. You probably saw me move this mini workstation. The way we carry our tools is on a mini workstation, which is carried on the front. Every single tool we use is tethered to us. We do not want to accidentally create satellites. Our primary way of remaining attached to the ISS, if we're not using our hands, are these waist tethers. And you can see they just have a big hook. They go around a rail or anything else on the ISS and latch on, and actually have a locking mechanism as well to hold us nice and tight. So we always want to have one of these attached if we're not holding on with our hands as well. The back of the EMU has our life support system. The life support system contains all the equipment we need, from a UHF radio down to the oxygen tanks that provide primary oxygen. And one of the challenges inside this sealed environment, it's very easy to carry our own oxygen with us, but we generate a lot of carbon dioxide, particularly when we're out there working very hard. So to combat that, to deal with that, we have these canisters called MEDOX canisters, which are just silver oxide. They are carried in the backpack along with a very large battery, which provides all the electricity for us. I don't have a battery here to show you today because we're in the process of charging them. We're about a month out from doing a spacewalk, and we've already started getting ready for that. So this MEDOX canister is able to remove about 7 to 8 hours of carbon dioxide that a human can generate inside your spacesuit. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view unbelievable. See you next time.
Hi, my name is Jeff Fitner, and I'm a logistics specialist on the rocket stream. This is rocket science in 60 seconds. Northrop Grumman is the manufacturer of the rocket boosters, NASA's Super Heavy Lift rocket, the Space Launch System, and we transport the boosters the same way we have for 3 decades, rail. The 21-car rocket train uses 2 engines, each producing 6,000 horsepower. It travels through Utah, Wyoming, Nebraska, Kansas, Missouri, Oklahoma, Alabama, Georgia, and Florida. That's a stretch of 2,800 miles over 3 railroads to deliver the motors to Kennedy. These rail cars are built to carry the immense weight of the 180-ton segment. It takes an entire day to load one segment on one rail car. Each segment is enclosed in a clamshell-like covering to protect it during travel.
Осталось всего 5 минут.
When you think of sea level rise and NASA, if that's the kind of thing you think about, I feel like it's only natural to imagine scientists poring over satellite data trying to better understand what's happening and what the future might look like on our coasts, including right here where I live in the Hampton Roads area of Virginia. My name is Joe Atkinson, and I'm a science communicator at NASA's Langley Research Center. This area is one of the hot spots for sea level rise in the country. Even on a beautiful, gorgeous, sunny day, we can have nuisance flooding just because of a high tide. But we'll get back to this area later, and specifically NASA Langley. The thing is, even as scientists are studying sea level rise, the agency itself is having to confront the reality of it. It has field centers and coastal communities around the country. I wanted to find out how seriously NASA is taking this threat. So I got in touch with a guy whose job it is to worry about this kind of stuff. His name is Calvin Williams, and he is the Associate Administrator for NASA's Office of Strategic Infrastructure.
First of all, I'd like to say thank you, Joseph, for the opportunity to speak to you about this. Sea level rise is a very major concern for us. We have about 2/3 of our NASA facilities are within 16 feet of sea level. And that comes to about $20 billion value of infrastructure that we have.
Now that long list of facilities includes Kennedy Space Center in Florida, Johnson Space Center in Texas, Stennis Space Center in Mississippi, Michoud Assembly Facility in Louisiana, Ames Research Center in California, and Wallops Flight Facility in NASA Langley right here in Virginia.
We have estimates that within the next 60 years or so, that there could be potential 4 feet rise in sea level. And so therefore we are trying to take measures now.
Now in broad terms, that means moving to higher ground or making facilities more resilient. At 2 of NASA's launch sites, resiliency equals the movement of lots and lots of sand.
For example, we've done some reconstruction work at Wallops and also at KSC, where we have stabilized the shoreline and the dunes there. And that's something that we have to replenish approximately every 5 years.
So you have to wonder, is this something that would keep Calvin up at night?
Well, it is at the top of our list. Definitely at the centers that are on the coastal areas. We want to make sure that we are taking the necessary steps to ensure that in the future we have launch facilities, research facilities that can continue the mission of NASA.
Now, Calvin talked about the beach replenishment efforts at Wallops and Kennedy Space Center. But I kind of wanted to dig a little deeper and find out what's happening at two of NASA's research centers, Ames on the West Coast, and of course, I wanted to know what's happening here at Langley on the East Coast. Since I work at Langley, I knew exactly who to go to, and that's Loretta Kellerman. She is the director of Langley Center Operations Directorate.
Certainly, we are a coastal center. It's on the coast. We're surrounded by two rivers, the York River and the James River, and along with the Chesapeake Bay. So a lot of opportunity for flooding and for sea level rise to present itself as a problem for our center. And so this is a big issue for us, and certainly one we've been addressing for some time.
Now, conservative estimates show about a 15-inch rise in sea level at Langley by 2080. More extreme estimates push that number as high as 49 inches, or about 4 feet. The center uses a flood tool as sort of a, I guess like a crystal ball.
This tool is a great tool developed by our geospatial information systems folks, our GIS team, that allows us to visually picture the rising sea level and which facilities and areas are affected.
In 2011, following a study that highlighted some of Langley's biggest vulnerabilities, the center, which is actually NASA's oldest, it's just over 100 years old now, began taking action in the form of a major revitalization effort. This effort aims to shrink and consolidate Langley's campus and minimize those vulnerabilities.
So we've been demolishing facilities that are in high vulnerable areas and building all of our new facilities and consolidating a lot of our missions into fewer facilities at our higher elevations. And for us at NASA Langley, our higher elevation is around 12 foot. And so we're not very high here.
Further complicating the issue at Langley is a phenomenon known as subsidence. The ground the center sits on is slowly sinking by about 2.2 millimeters a year. Now, if you add that to the 4.6 millimeters of sea level rise a year, let me do the math here, you're actually getting about 6.8 millimeters of relative sea level rise a year at Langley currently. The center isn't taking any chances. They can't pack up and head for the mountains, of course, but in addition to squeezing the campus onto the highest possible ground, they're also making really smart construction choices.
The study that we did in 2011, of course, recommended that we build all of our first floor elevations to 10-foot, 6-inch minimums, and that goes into our design requirements for all of our new facilities.
For Loretta, sea level rise isn't just a work concern, it's a personal concern too. She and her family live right on the water. But the communities in Hampton Roads are taking the issue seriously, and the federal agencies are too. So she takes heart in that, not just as a federal employee, but also as a private citizen.
I'm on the water. I always say I'm on the water or I'm in the water, depending on the storm that day. So you just never know. So it is a little personal and a little, drives a little anxiety, but I'm very encouraged by certainly the work that the city of Hampton's doing, and I think the things that they'll do will continue to support, and they're very engaged in the federal community here in Hampton, and I think all the things that they're doing are going to help our center as well, to try to move water out and away, from the city.
Okay, so now we're going to move all the way across the country to Ames Research Center, which is in Mountain View, California, right in the heart of Silicon Valley at the southern end of the San Francisco Bay. Now, when I reached out to Ames, they put me in touch with a guy named Garrett Turner. He is the Restoration Program Manager in the Environmental Management Division at Ames. And when Garrett thinks of sea level rise at Ames, he thinks back to 1998 and a series of storms that moved through the area. Now, this gave officials at Ames a big scare because it flooded the north end of the center and threatened to inundate a telecommunication gateway facility there, which actually would have shut down the internet for all of Silicon Valley.
We managed to keep that from happening by getting a lot of employees, both civil servants and contractors, to go and put sandbags out. And then we were able to pump some of the water in the channels over a levee into Stevens Creek. After that, we kind of decided that we needed to have a proactive way of at least addressing big storms.
Now, much like Langley, Ames, which is the second oldest NASA field center, decided it needed to look to higher ground. That decision was based on 100-year sea level rise projections.
We are now requiring a much higher minimum elevation for a new facility that gets built. So we have these little popped up areas. And our master plan has envisioned taking facilities that are in that 100-year floodplain and relocating them and relocating the entire campus farther south, which is several feet higher and has a much lower expected impact from sea level rise.
But there is a wrinkle here. It's not just the bay that's a problem at Ames. There's an old system of salt ponds and levees nearby that date back to the 19th century, and they further complicate things, and it's not a problem that Ames can just deal with on its own.
Levee maintenance is outside of NASA's property, and we can't go and fix all of these and keep them from pouring water into NASA.
One thing they're doing is working with the local water district.
We're working on trying to, figure out how we can reinforce those levees and potentially raise them. That we have, a bicycling and walking trail, the Bay Trail that goes around.
They'll have to look to their neighbors on either side for help too.
If we protect the levees immediately in front of us and they do nothing with theirs, we end up with the water just going over their levee and then coming in. So this is going to have to be a partnership, kind of regional with other stakeholders, to make sure that we can come up with a strategy that works for all of us.
One of those strategies is actually to turn those old salt ponds into wetlands, which would help slow the effects of sea level rise. It would also be a return of sorts to what once was.
Civil engineers have it perfectly. In the early 1900s, we drained all the swamps. Now we're creating wetlands. It's kind of reversing what we did before. So it's all part of the same training.
We've had a little change of scenery here, obviously. I wanted to wrap things up on my front porch here in Hampton. We're just a few blocks in from the water, and we're on relatively high ground. Still, worst case, long-term sea level rise projections would have me sitting in the water here. And even minor to moderate projections are pretty bad news for some folks right here in this neighborhood. Just a few miles across the water in Norfolk, that way, the high tide nuisance flooding I mentioned back at the beginning of this video is already encroaching regularly on urban areas and frequently makes city streets a gamble for drivers in all but the tallest vehicles. And so just as these coastal cities are having to deal with these wet realities, so too is NASA. When I set out to do this, I really had very little idea what NASA was doing to deal with sea level rise itself. Now, after talking to Calvin and Loretta and Garrett, I realized that there's a lot going on. In some cases, there are things that centers can do similarly, like move facilities to higher ground to help, but there's really no one-size-fits-all approach. Every place has its unique consideration. Ames has the levees and salt ponds. Langley has subsidence. Kennedy and Wallops have beach erosion to deal with. Staying ahead of this stuff is obviously a big, big job that requires a lot of expertise, foresight, planning, and coordination. Thankfully, it's a job that NASA is taking seriously. And it's a job that will allow NASA to continue its critical work in space exploration and aeronautics and earth science, even as the water keeps rolling in.
Hey everybody, this is Beck, and I'm a maker of music. And like the great Sun Ra said, space is the place.
And I'm Farah, I work at NASA, and I use AI to explore Mars.
And I brought a few friends along who know something about artificial intelligence.
Hi, I'm John.
Hi, I'm Isabel. We are both artists working with NASA using artificial intelligence.
This is Ask NASA.
Yeah, so Beck, you just released a set of new music videos using a lot of NASA imagery, and I grew up living space, and obviously those images are used by scientists. What inspires you about space, and how you came up with this idea?
Well, the title of the record came from a video game, a really primitive video game from the 80s called Asteroids. When the asteroids were going to kill you, and they were just about to collide with your spaceship, that you would hit this button and it would make you disappear and reappear somewhere else in the galaxy. And I always wondered what that button was called, and I looked it up one day, and it was called hyperspace. So I sort of, it got my mind thinking into music and song ideas. Because I think in some way, I think of music as sort of a hyperspace button. You know, it's something that we press play on a piece of music, and it takes us somewhere out of our lives, out of our circumstances. But I did like the feeling of the music, that there was this sort of thread of outer space, kind of wide vista of space and time, you know, existing in the songs.
Artificial intelligence is the ability for machines or computers to make autonomous and intelligent decisions. That can look like recognizing patterns or analyzing images or learning certain behaviors and then mimicking them.
I mean, right away when we heard hyperspace, we thought we have to use AI for this. Beck was already creating a sonic environment that went to the edges of our understanding and the way that we see. And that's something that we're most excited about working with AI with, that it expands our modes of thinking. And then just the title, hyperspace, literally means to go beyond 3 dimensions. The one that we use for this particular project, it literally works in a 512 dimensional space. The process begins with the AI training on the images. So if we showed it just a few hundred, it wouldn't know that much. But what was so great about working with NASA's decades deep, archive of knowledge is that it could really learn. So for weeks and weeks, the AI trained on as many images as we could show it. I think in the end, it looked at over 25 million images. Sometimes that was multiple times looking at the same images to try and understand these images.
Yeah, basically imagery of anything in our solar system is how we get started in the process of exploration, right? And so when we first went to Mars, or when we sent Cassini to Saturn, we had some thoughts about what we might find based on that imagery, and that's what allows us to really focus down on the type of science we're going to do.
I worked a lot on the database creation, and I feel almost like I could draw a picture of the galaxy now just from going, like anyone can do, just by working with the NASA websites and going through the archives. Like the AI was then able to take that and recognize colors that were happening a lot, recognize shapes that were happening a lot. I remember when it first showed us what it thought Saturn looked like, I was blown away.
Yeah, and even then, seeing these images and getting all the info, it is overwhelming, isn't it? I mean, we're talking about other worlds, we're talking about other realities we probably won't ever get to experience in our lifetimes. This is the closest we'll come to touching the unknown. This project is so interesting because it really came out of the theme of the record. I would have loved the idea of taking sounds from these missions in space and putting them into the music itself.
The coolest thing that we have coming up, which we can point you to when it comes out, is that Perseverance actually has 2 microphones on board, and it's the first time we'll have real audio from Mars. So we'll have audio as we're landing on the planet, so that during entry, descent, and landing, and then we'll have audio when we're driving, or the rover has a laser, and so you'll be able to actually hear that laser zap on another planet, which is kind of something that's kind of hard to even wrap your mind around.
And that hasn't been recorded before?
No, not with a microphone, not this way. We've never had a microphone on the rover like that.
Okay, well, send those audio files my way when you get them.
Absolutely. So on Perseverance, we actually have an extra computer, and so that extra computer allows us to make the rover smarter, and we actually self-drive on Mars. So the rover has to take imagery of the area in front of it, literally build its own map. It can then identify different types of obstacles and slopes, and based on that and its knowledge of where it's able to drive, it decides on the path.
The Mars database was in one of the easiest ones because it's where we have the most high resolution imagery. It's been so well captured from so many different points of view.
We've seen the soil on a terrestrial level, and then we also have imaging of Mars from above, and looking through this data set of massive data set of incredible images. Once we trained the AI on that, it was able to kind of produce such vivid, strange imagery, because Mars itself, I think, is so much more complex and so much more deep and varied than we imagine it is.
Okay, so one more cool feature about the Perseverance rover is that it can also act as a scientist. The rover can look at the environment around it, look at all the rocks, and say, hey, this rock over there looks really cool. Let me image it, use my laser to zap it and figure out what's under that surface, send all of that data back to the scientists. So it allows us to essentially have scientists on Mars making decisions without having humans in the loop here on the ground.
I think, to me, the idea of space is a bit overwhelming and awe-inspiring. Just the idea of listening to a piece of music and we go somewhere else, our lives change. You know, it's a mirror to this other idea of space and space exploration, and letting the imagery of these other worlds, these unknown places with this music, I think has been really satisfying to me. You know, I feel really fortunate to have you all open your doors to me and my music, and for us to go somewhere with it that was unexpected, even for me.
Let's use make his face or something.
Here, let me get my video up.
Sorry, guys.
We'll get it. We'll get there.
We'll get there.
NASA. This is Ask NASA. I mean, that would be the show tune way. There's all kinds of guitars. This guitar is actually from 1901, and it has these ivory pegs. All right, so these are some vintage keyboards. And this is the 808, which is responsible for the sound of all trap music. This is the Moog. And this is responsible for most of the music of the 80s. There's a couple of pedals that I use. Little bits and bobs.
By the time the Hubble Space Telescope was nearing its 10th anniversary in space, it had already become the gold standard for modern-day astronomy. Hubble had grown into an indispensable tool used by scientists all around the globe to take an inside look into the universe around us. Everything was great, flawless even, until something unexpected started to creep its way into the picture.
In the last month, namely in November 13th, the fourth of 6 gyros that are on board Hubble failed, and that left only 2 operational gyros.
Lights out. Hubble's gyros, which are needed to accurately point the telescope, were failing. What was NASA supposed to do? Cue Servicing Mission 3A.
And on Christmas.
Discovery Houston, go inside the cockpit. Next thing
So I propose no change, and then you tell us you go up there.
By 1999, Hubble was about to make its mark in the 21st century.
Discovery, go for Hubble release.
And as that turn of the century neared, Hubble was also due for another servicing mission.
I mean, you can just take it in, JT.
Just like the previous 2 missions to Hubble, Servicing Mission 3, planned for the year 2000, was going to upgrade and refurbish the telescope.
Hey, Store, Good. What do you think about you putting your tether on?
However, without warning, Hubble's gyroscopes began to fail over a year before servicing mission astronauts were scheduled to launch.
The gyros, of course, are required for the science mission. They're required for the extremely accurate pointing. We've homed in onto a wire there that is broken, and we think that is the reason why the gyros have failed.
So, Hubble needed 3 gyroscopes to continue to do science, and by April 20th, 1999, that's all Hubble had. Swiftly, NASA declared a Hubble emergency and split the upcoming servicing mission into 2 parts. Servicing Mission 3A would mainly tackle the gyroscope failures, and Servicing Mission 3B would encompass the rest of the maintenance that Hubble didn't need right away. It was now crunch time. Not only did NASA have to prepare an extra shuttle mission, but the astronauts now had to go into overdrive to prepare for the upcoming mission, now scheduled for October. And then, when everything seemed to be more under control, news broke. The 4th gyro failed.
Today, it's sitting up there with itself in safe mode. And that again shows how important the serviceability is to this facility.
Hubble was now in safe mode, which meant that the telescope's eyes were temporarily closed to science. The servicing mission was more critical than ever before. And after multiple maintenance and wiring checks delayed the shuttle launch, on December 19th, 1999, the team of Servicing Mission 3A was finally able to make their mark on history.
And liftoff of the Space Shuttle Discovery on a mission to repair the Hubble Space Telescope as we venture into the 21st century.
Houston Discovery, roll program.
Roger, roll, Discovery.
Houston is now controlling. The roll maneuver is complete. Discovery is now in a heads-down position, on course for a 28.5 degree, 310 nautical mile orbit.
Right away, the team of 7 astronauts went to work. This 8-day mission included 3 spacewalks to Hubble. The first of which replaced all of the gyroscopes. Now Hubble was able to be accurately positioned and stay locked on to its celestial targets. Not only that, the team behind Servicing Mission 3A refurbished Hubble's fine guidance sensor for even greater precision in pointing the telescope, fixed damaged thermal blankets that protect the electronics housed inside of Hubble, installed a new computer 20 times faster than Hubble's original computer, replaced old tape recorders with a new solid-state recorder for greater efficiency in Hubble's data management, and fixed the spacecraft's S-band transmitter to continue to relay data to the scientists on the ground. And on Christmas Day, 1999, Hubble was released back into the stars, ready to uncover new discoveries that lie ahead. Servicing Mission 3A proved that NASA could not only be quick on its feet in dire circumstances, but perform as a team that is united around keeping our eyes open to the universe for many years to come.
We've all played these claw games before where it can be really frustrating using a grapple to pull a toy out of a machine. Well, the success of NASA's InSight mission depends on a grapple. Let's learn about it on this episode of Crazy Engineering. All right, we are here at the InSight Lander Surface Test Bed. This is Nick. He was one of the key engineers on the grapple mechanism. Nick, thanks for joining us.
Sure.
If we got this grapple, what does it do? What's its purpose?
So its purpose is to grab the instruments so the robotic arm can then lift them and place them down onto the surface.
When I play these arcade games, right, they're really hard to get that toy out of the game. And you're using a mechanism that kind of reminds me of that. Is that a good idea?
So the mechanisms themselves, although they look similar, are very different. With the arcade game, when you grab that stuffed animal and you pull on that stuffed animal, you actually open the claw fingers and that stuffed animal falls out. With the Insight grapple, that mechanism is designed to latch. So once those fingers are closed, it's impossible to pull on those fingers to open it.
So how does it work?
So the grapple has 5 fingers, and we designed this grapple to maximize our success. It uses a wax actuator to open the fingers. We grab onto little hooks at the top of each instrument, and then the robotic arm picks those instruments up and places them down on the surface.
You said wax, that we're using wax to open and close the grapple?
Yeah.
Why do we use wax? Why don't we use a more typical solenoid or an electric motor?
It's actually a thoroughly proven technology. It's used in space applications like the Insight grapple, but it's also used for decades in things like our car thermostats and our appliances at home. It uses a heater to melt some wax inside of a little housing. And when this wax melts, it expands and it develops this hydraulic pressure. And that pressure pushes out a rod, which we use to actuate our mechanism.
Once it's completed its primary function of putting the instruments down, what does it do after that? How does it get out of the way for other things you want to do?
So there's actually another hook on the side of the robotic arm, and the robotic arm can maneuver itself so the grapple can re-stow itself on the side of the arm. Then the arm is free to essentially do whatever it needs to do.
Nick, this grapple mechanism is truly unique. It's really fun to learn about. Thank you so much for bringing us into the test bed and answering all these questions. And as always, thank you out there for paying attention, and check back here for some more crazy engineering.
For me, I've only done airborne field work, which is very different than being on a ship, and where it's just very isolated. Like, that ship is really your whole world, and all those people on the ship are your whole world. And then outside the ship is this just very hostile landscape. It's cold, there's polar bears, there's water that can open up underneath your feet. And so it was a very interesting experience to be on the ship, which was very safe and warm and felt good. But then we'd go out and we'd do our field work, and we'd set things up, and we'd be out on the ice, and you could feel like this is a very wild environment. As we were transiting through the ice, we were searching for a suitable ice flow, something that was thick enough that could support us working on safely and also survive throughout the year. While searching for that flow, we had different satellite tools that we were using that would identify the shape of the flows. We could see how big the flows were, but what we didn't know was how thick they were. We went to some of these flows and we found, though these are really thin, we can't actually use this flow. We looked at some ISAT-2 tracks in hopes that some of the flows that we had identified, we could see how thick they were. It didn't work out this time, but for a future expedition, I think we've identified ways that we could utilize ISAT-2 or something like ISAT-2.
While there wasn't enough ISAT-2 data for MOSAIC or the Multidisciplinary Drifting Observatory for the study of the Arctic climate to use, Dr. Nathan Kurtz and the team were able to locate an area with the right amount of sea ice thickness by using different methods. Likewise, scientists often use various methods to measure other aspects of our planet, like forests. So, why take measurements of the same thing using different methods? And how does measuring sea ice thickness relate to tree height? Let's take a closer look at the Ice, Cloud, and Land Elevation Satellite, or ISAT-2. Its main purpose is to measure ice thickness using its sole instrument, ATLAS. But it also measures tree heights as it orbits Earth. This is done with photon counting lasers and algorithms developed to differentiate what environments they are measuring. An algorithm is a step-by-step procedure for solving a problem, usually a mathematical one, in a limited number of steps. Claudia Carabajo was the deputy lead for the Flight Science Receiver algorithms, one of many subsystems of the Atlas instrument.
The algorithms that process the data on the ground for ISAT-2 are tailored directly to address that characteristics of the surface. So they are tailored to sea ice and vegetation. The coherence of those photons when reaching those surfaces changes, so the algorithms need to be specifically tailored to the surface type. Of course, comparisons against other data sets help you, and sometimes you need the help of an additional data set as you're processing.
When I was on Mosaic, we took specific measurements that are useful and will be used. By combining multiple measurements together, we're able to quantify and see whether ISAT-2 is making its measurements accurately and how it's needed to be done.
One of the ways that you can actually figure out if ISAT-2 is actually measuring the right thing is to compare it with the observations that are being collected by other means. For example, airborne campaigns, other satellite data, and see what the surface looks like. You can look at how things are changing at different seasons.
Whether it's sea ice thickness or tree height, comparing data collected by different missions and field campaigns allows scientists to better understand how the instrument works. Dr. Laura Duncanson uses LiDAR data to create 3D maps of forests, and Dr. Nancy Glenn is currently looking at various ways in which tree height data collected by ISAT-2 and GLOBE observers can be utilized. For both, tree height data adds to our understanding of Earth's systems.
Of course, we can't go out into the woods all over the planet and measure every single tree on the ground. So for ISAT-2, these estimates of tree height, we don't know exactly how precise they are, or how good they are in all of the different forests around the globe. There's a lot of variability in forests.
Just like how taking field observations and airborne data collected of sea ice thickness can act as supplementary data to ISAT-2, tree height measurements collected in the field can also be used to do the same. This supplementary data can help scientists account for variability between different environments when looking at measurements collected by satellites. As mentioned, tree height measurements can be taken in different ways. One method is to use trigonometry to estimate the height of a tree. This is the method that students and citizen scientists use. By measuring the distance to the tree, along with angles A and B, using a handheld clinometer or the one built into a smartphone, observers can calculate the height.
Having people go into the woods and actually measure tree height to compare to the satellite estimates of tree height gives us a sense of how reliable those tree height estimates are, and maybe some ecosystems that they're particularly good at doing tree height or particularly challenged at doing tree height.
Now we know that by taking measurements of the same thing, using different methods can help scientists. Taking tree height measurements adds a whole new data set for satellites and instruments such as ISAT-2 and JEDI to compare with. These measurements also provide content that only an observer on the ground can provide, like recent changes including drought, fire, invasive species, and more. Now that leaves the question, why do scientists study trees?
So for decades now, we've had really good maps of where there are forests and where there aren't forests, but we've never before known how tall the trees in those forests are. And this is a really critical piece of information because it tells us not only, of course, how tall the forests are, but how much above ground woody carbon they store. Forests represent one of the biggest carbon stocks on the Earth's surface. And if we cut down and burn forests, we essentially are pushing more carbon into the atmosphere. And if we allow those forests to regrow, we're sucking that carbon out of the atmosphere. But we don't know right now how much carbon is where in Earth's forests because we've never had that third-dimensional measurement of Earth's forests, which is so tightly linked to its carbon content.
Using tree height not only helps scientists track how much carbon is getting released into the air, but can also be used in other ways.
Tree height is really important for us is that we're interested in knowing how tree height is affected by increased CO2 or increased temperatures or decreased temperatures. And that gives us an indicator for making predictions about trees in the future. we're interested in is that trees and the differences in tree heights provide some level of what we call structural diversity. And structural diversity can be really, really important for a health of an ecosystem, as well as provide habitat for a variety of different types of animals. So we're using NASA resources, NASA airborne data, as well as satellite-based data like ICESat.
Many Earth-observing satellites, such as Landsat, can only see a top-down view of Earth. This information comes in the form of two-dimensional images made up of pixels between the size of 30 meters squared to 500 meters squared. But now, with JEDI on board the International Space Station and the launch of the ICESat-2 satellite in 2018, scientists are able to see height added to this top-down view of Earth. By taking and submitting tree height observations, citizen scientists and students can help scientists and researchers, not just by providing measurements from different ecosystems, but by providing a different type of data. What seems like such a small piece to contribute can help scientists across the world.
The Globe Observer tree observations essentially let people all over the world measure tree heights and give us that information where we can't go into every single forest ourselves as a small group of scientists.
From a scientist's perspective, but also somebody that participates in citizen science, gets a great intersection. More data, the better. But also the connection, right, is that the connection between scientists and the community, and scientists understanding what's important to our communities and being able to engage and learn from one another.
There is a large part of collaboration between the instrument scientists and everybody working on every aspect of the Atlas instrument, and the mission scientist and his deputy and everyone else in all the universities. Citizen science is really important to get the community involved. It motivates everybody to be more informed about the science, and also perhaps motivate a crowd of new scientists.
All of this is important because one, it's the pursuit of answering questions about our natural environment. Our natural environment is changing very rapidly.
A tree height measurement that's taken by citizen scientists could be useful for us.
It's really important for us to monitor what is here now so we can document that, but also use that in models to predict what might be here in the future.
To learn more about Globe Observer, check out the website at observer.globe.gov and download the app to start taking your own observations today.
Welcome back. I'm Joshua Santora, coming to you from near the Kennedy Space Center. When I left you last time, I thought we would be in full swing of launch preparation, but we've had a couple delays, and so we figured we'd take time to hit another episode in our series of how the NASA's Kennedy Space Center is enabling deep space human exploration. Today we're going to hit on Gateway and how our commercial collaborations and partnerships are helping us explore and even pioneer new worlds. Gateway, in short, is an outpost that will be orbiting the moon that will enable us to reach a variety of locations on the moon's surface, as well as travel to Mars and other deep space destinations. It is a multi-center effort, and the Kennedy Space Center has been given the responsibility of the logistics element. So to learn more about what that is and what's involved with making logistics happen, I'm joined now by Jeff Smith, who is the element architect for deep space logistics. Jeff, how you doing today?
I'm doing great. How about you, Josh?
Thanks. Yeah, I'm doing really well. Always excited to talk about Gateway. It's one of those projects where every time I talk to somebody about it, I feel like I'm learning so much more. So excited to hear from you. Tell us more about your specific role with Gateway.
The Deep Space Logistics Architect looks forward at what are the crew and the cargo needs going to be in the next 3 years, the next 5 years, the next 15 years. It's my job to try to understand all of that and then boil it down into something real and implementable that we can go do.
I mentioned a minute ago that this is a multi-center effort and Kennedy has a piece of that. Can you unpack for me a little bit more what is this logistics element and Kennedy's role in making that happen?
Yeah. The logistics element is one of the modules of Gateway, one of the parts of Gateway. Gateway, in its very early phases, will have a power and propulsion element and a halo element, a habitation and logistics outpost element. That's two small parts. Only the halo element actually could have people in it. Orion will dock there, the human lander system will dock there, and a logistics vehicle will dock there. That's where we come in. So the logistics vehicle, this Dragon XL in this case, our first contractor and partner to be able to fly to the Gateway, that vehicle, it really doesn't look like the Dragon 2 capsule that just brought crew back successfully from the ISS, but under the hood, it's all the same, only with a couple of little tweaks and a much bigger section for putting cargo in there.
Jeff, just listening to you today, I think I had an aha moment. I've been envisioning this as a one-time, one-and-done situation, but it sounds like that's not the case, that this is actually a recurring mission. Is that true?
It is a recurring set of missions, and we're nominally expecting maybe one mission per year over the lifetime of Gateway. The vehicle will be loaded with over 5,000 kilograms of cargo and supplies and experiments and other types of things. It'll go up autonomously docked to the Gateway. Then it will stay there for up to 1 year while the crew come and do their sorties to the lunar surface or other work that they have to do. After the crew have left, the trash will have been loaded into the Dragon XL, and in an autonomous fashion, Dragon XL will depart and then go into a disposal orbit, probably somewhere going around the sun, where it will be safe and not interfere with other missions.
As the series suggests, and as NASA missions are clear, the moon is not the final destination, although it's really important. We're headed to places further, Mars and beyond. So how is Gateway enabling that sort of exploration beyond the moon?
This is going to be the proving ground, where we've gone from ISS and low Earth orbit, where we're only just a few hours away from help should we need it. We're moving out to Gateway here, 240,000 miles from Earth, several days journey to get there or to get home if something needs to be done. Gateway is going to really increase the level of independence that the crew need to have in order to do the operations in this remote environment with longer and longer time delays between Earth and Gateway and then eventually Earth and Mars communication. Gateway is going to be the proving ground for all of that. And then when we do need to start moving on to Mars, Gateway is a great staging point. It really doesn't take a lot of energy for a vehicle that's docked at Gateway to then boost itself into an orbit that can take it all the way to Mars, a Mars transit orbit. So Gateway is going to stay a part of our program for a long time as that staging point, that hopping off point to Mars.
Jeff, can't thank you enough. I appreciate you being here. Good luck to you and the entire team. I know there are some very fun and exciting but very busy years ahead of you guys.
Thank you. Thank you, Josh. Great to talk with you.
There's no mystery that we're relying heavily on SpaceX and the Dragon XL to make the logistics element for Gateway happen, but they are far from the only company that is helping support our exploration efforts. To unpack more about the broad look at commercialization and exploration, I'm joined now by Mary Fowler, who is a senior mission manager with the Launch Services Program, and they call the Kennedy Space Center home. Mary, thanks for joining me.
Absolutely.
Mary, looking at the past of kind of the way NASA's done business with our big space programs, we have done a lot of dictating to contractors for things like the space shuttle. We're owning this process, but now we're shifting gears, and this commercialization really means that we are operating like a partner. Can you tell me more about the changing landscape and what that means for us?
Well, so NASA LSP, we've actually been doing this for over 20 years. Launch vehicles have been launching commercial for decades, obviously. So, historically, NASA bought hardware. They owned everything. They owned it from the design. They owned how to build it. But now we're transitioning into buying just a service. So we just say, we need to go up into this orbit, get us there. I don't care how you do it, just make sure it's safe. And so we don't own all of the interim steps. And now we just have targeted insight into what the contractor's doing so we can knowledgeably agree with what they're doing. And then we have also very targeted approvals, kind of in those very high risk areas or mission unique areas, and allows for a lean team and allows for the industry to really innovate for us. So stepping back and understanding where we can take a little bit more hands-off approach has really allowed this significant cost savings and more missions to actually go forward rather than just a handful of really exquisite, expensive missions.
Yeah, thanks for kind of talking about some of those benefits there. Appreciate that. Obviously important to talk about those, but I'm guessing that it's also brought some new challenges with it. So where are the growing pains for us, and what are some of the challenges with this new operating model where ultimately we're relying more on commercial companies?
So it's really a cultural shift for most of NASA. Trusting the industry to do the right thing is always hard because NASA does it pretty darn good. So allowing the ownership of those items to reside with industry and letting go and of the telling them how to go do everything versus a more commercial approach of focusing on what we really need to be delivered. And in the end, not a step-by-step approach of focusing on how they need to get there, right? We just need what they are going to provide. Also, commercial entities, they are now responsible for the mission success. It will be perceived that NASA has a failure if there's a failure, even if that responsibility lies with the contractor. So that's really needing to manage expectations of the public and, you know, everybody else who thinks that this belongs to NASA and you need to own it. That's the challenge.
Last big question for you today. Is this something we can expect to become a staple? Like, is this the model going forward where we'll see broad partnerships and collaborations for human exploration?
So really, as the commercial companies, they see the benefit of commercially exploring space, the industry base, the customer base grows. There's real excitement of pushing humans beyond low Earth orbit, going to the moon, going to the Gateway, going to Mars. So that's going to continue as that industry grows. There's no going back. It's just a much more efficient and effective way of doing things.
Mary, a big thanks to you for your insight and expertise and taking time to talk to us. Obviously, Launch Services Program has a huge part to play in the robotic explorers that will be a part of our sustained presence on the moon and beyond. So good luck to you and your entire team.
Thank you very much. I really appreciate it.
All right, that's going to do it for us here today. Now we think we're going to take that break for these amazing launches coming up. Specifically, the two that are the most noteworthy are the Crew 1 launch from the Kennedy Space Center and the Sentinel-6 Michael Freilich mission from California. So please check those out, nasa.gov for more information on those. Another big thanks to Jeff and Mary for their help today. And remember that even the sky isn't the limit.
Hi, I'm Dr. E. Ellen Stofan, and Dr. Z, Dr. Thomas Zurbuchen, and I would like to answer some of your questions. Let's see. It says, my 11-year-old space enthusiast wants to know, what does NASA want to accomplish on the moon when humans return there in the next few years?
I really want to answer that question in two parts. The first one is we want to create the capability not only to go to the moon, but going to Mars. Those technologies, together with the commercial and international partners that we work with, will bring us there in a way that we can turn around and move towards Mars. We've never done that, and we want to increase the sphere in which we can explore with humans. What an amazing thing. But there's a second part, and that is that we want to do science and exploration of the surface of the moon. There are interesting questions that we want to answer there about the age of the solar system, about the history of the Earth and its bombardment and so forth. Early in the Earth's history, we want to learn about water and many of the questions about this body that is our neighbor there in space. And those questions we want to answer with experiments that we're developing right now. Okay, I'll ask you a question. Did Mars or Venus host ancient watery environments conducive to early life? And is there evidence that life emerged?
You know, that's one of the things that has really driven some of our exploration of those two bodies. For Mars, the answer is definitely yes. You know, we've long known that Mars has channels carved by water across its surface, but all of our spacecraft have helped us hone in on the fact that Mars probably had surface liquid water as much as an ocean's worth from about 3.9 or so billion years ago to about 3.5 billion years. During that time, the conditions existed in which life could have arisen, and we're still trying to figure out, did life actually evolve on Mars or not? And with our next mission to Mars that's going to be launched this summer, we're going to be looking into that very question of, can we find more evidence? Did something looking towards life actually evolve on Mars or not? So we have a lot of questions about that. Venus is actually an interesting story because back in the early 80s had a spacecraft that measured the isotopes of hydrogen in the atmosphere of Venus, which told us that Venus probably early in its history lost an ocean's worth of water. So it had a lot of water, but as Venus evolved, it lost that water. Some models suggest that Venus indeed could have had an ocean, but we want to go back to Venus and really measure the chemistry of the rocks on Venus, because that's what's going to help us answer that question.
Talking about places with potential life, let me ask one more question, which is, I'm interested if we ever go and send a real probe to Europa to see if there's really anything in that ocean under all that ice.
One of the things we want to do with the Europa Clipper mission is actually go look at where we think there are plumes of liquid that are erupting from that subsurface ocean out into space. And if we can analyze some of those materials that are coming out of the interior of Europa, look on the surface where the material from those erupting plumes would fall, we're hoping that we can understand more of the chemistry of that subsurface ocean. Eventually, obviously, what we would love to do is land on the surface of Europa where we could make better measurements and try to understand, could there be life in Europa's subsurface ocean? And scientists and technologists have even come up with concepts for spacecraft that could land on the surface and maybe melt their way through the ice to go and explore that subsurface ocean. But those missions are probably a couple decades out. This is a fun question for right now, and in fact, I was just thinking of doing this today. How would sourdough starter thrive in space? Do you know that one?
I'm actually interested what you came up with when you thought about that earlier today.
It's interesting because I've gone out to classrooms before and done an experiment with yeast to help kids understand the idea that different conditions on different planets can affect life. And so we've done an experiment where we put yeast in hot vinegar, and we put yeast in ice water that is super cold. We microwave it and then put it in water. And it's amazing. Actually, the yeast still is active. All those harsh conditions make it a little less active, so it bubbles a little less. But yeast actually only needs sugar and moisture and warmth to start activity. And so it doesn't really need oxygen. So I thought that was an interesting thing. I didn't realize it didn't need oxygen. I did think it needed oxygen.
You know what's amazing is how general these principles are applicable throughout the universe. And actually going on a space station, where of course the astronauts have big cookies up there. It's kind of one of those exciting experiments. There's many others.
Thanks so much. This has been really fun. And I can't wait to do our next episode of Easy Science.
This was once just a dream.
TTC, TTC go. TTC, TTC is go for launch.
2. Booster ignition and liftoff of Discovery and a team of explorers shaping their destiny.
An answer built by those who dared to ask. What if we were to channel humanity's knowledge and creativity into something truly revolutionary? What if we built a bridge between and above all nations? To jointly discover the galaxy's great unknowns, to endeavor to live and to work outside our planet for the benefit of all within. What started as an accord between two former rivals became a beacon of opportunity for the rest of the world.
We have ignition and liftoff of the Soyuz rocket, beginning the first expedition to the International Space Station and setting the stage for permanent human presence in space.
You ready for visitors?
We live this dream aboard the International Space Station.
Understand it's good to have you there and adjusting to your new home.
Adapting to life in space. It's been a process.
For the past 20 years, over 230 astronauts from all over the world have worked tirelessly together, boldly performing pioneering research and high-stakes spacewalks in the unforgiving environment of space. In this unparalleled orbital laboratory, circling the planet at 17,500 miles an hour, thousands of groundbreaking scientific experiments from over 100 countries have led to discoveries unachievable in the confines of Earth. From 250 miles up, an unbroken chain of residents have shared their view and their research with a generation eager to understand this higher plane. The space station is a symbol of humanity at its best, a shining example of international peace and collaboration in action.
3, 2, 1.
Endeavour, this is Houston. You've completed a historic ride to the ISS and have opened up a new chapter in human space exploration.
And as we turn our gaze outward still, this International Space Station is a living testament of our collective strength and perseverance, where our human curiosity prepares for the audacious efforts ahead. We continue to bridge the distances between us and prove just how much more is possible when we dream together.
A new era of exploration is beginning. NASA is building on its experience in low Earth orbit and preparing to go farther, setting up a base camp in orbit around the Moon, known as the Gateway, exploring the surface of the Moon like never before, and preparing to one day go to Mars. To accomplish all this, NASA will need a new spacesuit for its astronauts, one that's more flexible, versatile, and durable than any made before. Engineers are now hard at work designing, building, and testing the new suit, making sure it's up to the task for future exploration. Some of the greatest moments in exploration have taken place with a human in a spacesuit. Whether it was a first journey outside the spacecraft or traversing mountainous moonscapes, the spacesuit made it possible. The act of sending a suited human outside the spacecraft is called EVA.
What is an EVA? EVA is an acronym that stands for extravehicular activity, which is what most people know as a spacewalk. It's whenever we take astronauts and we let them go outside to do useful work in the vacuum of space.
The spacesuits currently in use for NASA EVAs were designed in the 1970s for space shuttle missions. They have been upgraded over the years for work on the International Space Station and have served NASA well.
In the past 20 years, there are a handful of types of spacewalks that we've done. We've done planned spacewalks for maintenance. As hardware breaks, we can do contingency spacewalks. As technology improves, we can upgrade hardware. Or like with the Hubble Space Telescope, we're actually repairing very sensitive scientific experiments in order to enable science.
Those EVAs took place in microgravity, where astronauts float and need to use their hands to move from place to place. But moonwalkers, working at 1/6 Earth's gravity, will need spacesuits that let them use their hands and feet, walking to destinations and bending and reaching as they explore. For this new type of work, NASA has been testing prototype planetary suits, culminating in a new suit design, the XEMU.
The XEMU is Exploration Extravehicular Activity Mobility Unit. So it's an exploration spacesuit. So it's a spacesuit that you're going to use as we move forward on Gateway missions and on the lunar missions with Artemis. And then we're using all that to test the suits you would want to use to go to Mars in. So eventually you're going to have to be very independent and very confident in your hardware when you go and do a mission that far away from Earth.
One of the most obvious changes in the new spacesuit is the way astronauts get in and out of it. Donning the current suit is a multi-step process of wriggling into the upper torso and then getting help attaching a pair of space pants. The new generation spacesuit features a hatchback, where astronauts simply slide in and out of the one-piece body of the suit.
I feel much better.
Another big feature of the suit is the way the astronauts are able to move while wearing it. Apollo astronauts learned they had to hop to get around on the moon. The suit design sometimes made it difficult for the astronauts to work.
Up. Okay. We see that one went all the way in. Not quite. Like that.
Engineers learned valuable lessons from those Apollo suits. The improved design for the next generation spacesuit will allow astronauts to walk on the moon, not hop. Additionally, astronauts will experience an improved range of motion.
The new suits, the planetary walking suits we're working on now, we really hope to provide improved mobility and comfort along with reduced injury potential. And really, like I said, provide the best tool to the crew member that we can provide. Then we want to be able to provide them the ability to kneel down and pick up a rock, like they're going to want to do in their geology science that they're working on. We want this to be a very reliable and durable suit so they can use it day after day in a dusty environment and not have to do a lot of maintenance with it while they're needing to do their mission. So there's a lot of those kinds of aspects that go into improving the suit that we're going to provide for the lunar missions.
Improved mobility is not the only feature engineers have been working on. The astronauts will also be carrying a special backpack known as the PLIS.
So the PLIS is the Portable Life Support System. It's the backpack on the spacesuit, and it has all of the interesting parts to keep the crew member alive while they're on their spacewalk. So it has oxygen stored as pressurized gas for breathing, pressure regulators that regulate the oxygen pressure inside the spacesuit, and then a ventilation loop and a water loop that we call the thermal loop that provide trace contaminant and carbon dioxide removal from the breathing environment, and also cooling for the crew member and the suit onboard avionics and electronic systems.
While the PLIS has been on previous spacesuits, this improved version will offer new technology, greater control of its systems for the astronaut, and longer life for each EVA, allowing more exploration.
The PLIS labs are awesome, super fun places, and we physically assemble the parts to build the life support system, and then we test it. It's our opportunity to find things and fix things before we get it on orbit. We love what we do. We really want to see the system fly and be useful and help a person explore the moon in a more capable manner than they were able to do during Apollo. So it's a great job.
So I want you to perform some isolated joint movement to understand how the suit moves and then be out.
Testing for the new spacesuit continues underwater in the Neutral Buoyancy Lab. Here, the weightless environment of space can be simulated to put the suit through its paces.
So being able to test the suit in the pool and microgravity environments allows us to iterate on our design and make it better and get feedback from astronauts and from other instructors and trainers.
Could you reach all the way across and do the cross switches with your opposite arm?
Oh yeah, it's really easy to get all the switches with my opposite arm. I would rate this as excellent.
Come on. I know, I guess gotta get lower and flatter.
Yeah.
Hold on. Oh my God.
You did it! Very good.
So if this could happen in real life, this is a spectacular translation. Rex and I are very lucky. It is like a brand new spacecraft.
Even
even has the new smell and everything.
It does. New car smell.
Spacesuits are also tested in the Active Response Gravity Offload System, or ARGOS.
Yeah, so the Argos electronically is able to tune an astronaut exactly to whatever gravity it is that we're practicing that day, whether that's microgravity, lunar gravity, or Martian gravity. The other nice thing about Argos is you're able to get the instructors and the engineers right next to the astronauts as they're working, helping the astronaut figure out a problem as they work through the development of that test for the suit or for a piece of hardware and get that real-time feedback.
Spacesuit hardware is not the only thing being tested on Earth. NASA is looking at human performance as an important factor in designing EVAs and spacesuits.
So related to a spacesuit, a lot of times people think about the actual engineering, the hardware, the different pieces, but I want to look at the EVA scenario from the human really inside the suit and make sure that their performance, both physically, cognitively, is going well. So we want to look at things like physical exertion, cognitive workload, injury risk, and really just trying to make sure that they're not impaired by the EVA system any more than they have to be.
The NASA team uses virtual reality technology, motion capture, and other tools to study what it takes for a human to conduct an EVA.
And what we're able to do is bring actual, no-kidding data to the table that really removes the opinions. That's probably our primary benefit for how we kind of enhance the EVA community is we take a look at this not from a hardware, not from an operations standpoint first. We look first at the human and then kind of say, what do they need to be able to do to be ready for the job?
All the work on the spacesuit here on Earth is building up to the ultimate test, to fly it in space.
So we're actually building a flight unit of that XEMU, and we're going to launch it to the International Space Station. And we will do an EVA with a current spacesuit, an EMU that we use today, and the XEMU with it. We'll go out in pairs and we'll have the astronauts working together, one in the old suit and one in the new suit, and we'll test its functionality in a microgravity or a low gravity environment out in the vacuum of space. That will help us test a lot of its systems.
The EVA on the space station will set the stage for the future, when the suit will need to perform a variety of missions beyond low Earth orbit.
Yeah, so a great example is NASA's Gateway. So even though it is in lunar orbit, it's still a microgravity platform, so astronauts would still be floating in space. And so we can use a lot of the lessons we learned from the International Space Station to do spacewalks on the Gateway. It's actually really advantageous to use one spacesuit both at Gateway and on the lunar surface. So the exploration spacesuit can do both of those things.
For EVAs on the moon, the new spacesuit will give astronauts unprecedented abilities as they explore the lunar surface.
Really, this is the first time we're trying to bring a suit that's optimized for human performance and optimized for lunar exploration so that you can actually bend down, interact with the ground, so that you're going to have the visibility that you need, the mobility that you need to accomplish these tasks.
This new suit will allow us the flexibility to really do exploration. Get down on the surface and send geologists to the surface and really let them act like geologists in a spacesuit. This is the first time in history that a suit like that will have been created, and it's really exciting to be part of that. To do what NASA was meant to do, and that is to do exploration. And this suit will really help enable the agency go do exploration.
Well, everyone in my generation wasn't alive the first time we went to the moon, and we want to do it again, and we want to do it better. We want to go do more science, we want to stay longer, we want to get more out of it, and we have the technology to do it now. So we're really excited about it.
With its new technology, new design, greater mobility, and greater versatility in how it can be used, NASA's new spacewalking suit is truly tailored for the next generation of space explorers.
Welcome to NASA Edge, an inside and outside look at all things NASA. Today, joining us is Terry Fong, who is the Deputy Rover Lead for Viper at NASA Ames out on the West Coast. And thanks so much, Terry, for joining us even late in the day for us.
Sure, my pleasure. It's always great to talk with NASA Edge.
Well, we've had a good time working together in the past, and that's why we're really excited to talk to you today. We just witnessed the Mars 2020 launch for the rover Perseverance, but now we're moving on to Viper and want to find out what's going on from Viper's perspective. Can you give us an update on the Viper rover and where things are at this point?
Sure. Viper is NASA's first rover mission that's headed towards the moon. We're really excited. Hope to launch that towards the end of 2023, so a little bit more than 3 years from now. Of course, Viper is a very different kind of mission. It's really different than the Mars rover missions. Whereas those missions were focused on field geology on Mars, here we're going to the moon to hunt for subsurface volatiles, basically buried water ice.
And I take it that that's really, really important as we explore space, because in situ resources are really what we believe, or what NASA believes to be the key to sustainable presence off the Earth's surface.
Yeah, I think it's really important for us to try to live off the land. At the moment, anything we want to do in space requires to bring everything with us, whether it's water or oxygen, food, fuel, all that kind of thing. And to the extent that we're able to actually make use of other resources, for example, if we can make use of the oxygen and hydrogen that we know is on the moon that's trapped in the soils, then we can, not have to carry it all with us from Earth. And I think if Viper is successful in a few years, we'll have an answer of where are these materials located? Can we get at them? Can we make use of them? And that will frankly change everything in how we plan for future space exploration.
Where are you guys targeting to land Viper and do that exploration on the lunar surface?
Yeah, at the moment we are targeting landing near the lunar South Pole. It's interesting, the moon also has interesting places in the north. If we were to shift 6 months later, we might land towards the North Pole, but right now we're targeting the South Pole for a couple of reasons. One is that it is a place where the LCROSS mission impacted. That was in the Cabeus crater, and where we got confirmation that there is a subsurface water ice, and also because it's the target location for Artemis. And for those reasons, we are targeting at the moment to get towards a South Pole site with Viper.
That's interesting, thinking of LCROSS and where it landed, but obviously whether you go to the north or the south, you have clear objectives in terms of the kind of science you guys are planning to do with Viper. Can you tell us a little bit about that?
Yeah, Viper is a prospecting mission. We're looking for primarily subsurface water ice. And to do that, we're carrying actually a total of 4 instruments, 3 spectrometers and a drill. The drill allows us to get down to up to a meter below the surface and pull material out. And we take this material and we use the spectrometers to analyze the content of different minerals. And in particular, we're looking for different types of hydrogen. Hydrogen being sort of the gold that we're looking for, so to speak, on the moon. Because of course, hydrogen combined with oxygen that we know we can get from the soils on top will allow us to make water and to make fuel, frankly, for future rocket systems.
I'm sorry, that seems a little complicated. I mean, I know it's a known thing. You really believe that if you have these necessary components, you can bring the technology there that will allow you to turn these raw materials into usable resources?
Well, that's actually, a key question that we're trying to answer with Viper. It's not enough to know that, oh yeah, there's hydrogen, in the subsurface, in the soils. We need to know how much of the soil actually has hydrogen. Where is it? Is it really deep? Is it shallow? How much of it is there? Because, only with that information can you plan, okay, well now I know how deep and how much I need to actually excavate and how I will then have to process the soils in order to get at the hydrogen. It's the same kind of thing that we see here on Earth. Any prospector who's going out hunting for things really wants to know the overall ore grade. That is, the quality of the material that you're going to be mining or extracting. And the same thing's true for lunar fuel.
And I guess that's where the other instruments come into play, because you'll be able to do that kind of analysis right there on the rover as you're exploring the moon.
Yeah, and again, this is a difference, I think, between Mars rovers and Viper. Here we're trying to do real-time prospecting. So the data from the instruments on Viper will come back to Earth in real time, will be live, fully interactive with mission control and the science team on the ground. We're going to be driving the rover actually a pretty long distance, up as much as 20 kilometers over the course of, say, 100 days. Just in comparison, Curiosity, I think it took it over 6.5 years to go 20 kilometers. So, a bit faster, but that's driven by the fact that we are basically prospecting. Our goal is to try to cover as much ground, to go to as many different kinds of regions where we believe the ice might be on the surface, might be shallow, might be deeper, and really just to build up an overall picture of the resources and where they are, what the concentration is, and frankly, how hard it's going to be to get at them if we want to make use of them later.
Even though we haven't determined where we're landing on the moon when we return, if VIPER is successful in identifying sort of mineral or resource-rich areas, that's got to help mission planners determine where the astronauts could potentially land.
Yeah, well, clearly, you don't want to, land, thousands and thousands of kilometers away from where your gas station is. That just would be really bad planning. You would like to go where you're going to be, basically extracting fuel, or at least, the components to make up fuel or water or whatever. And of course, you're going to have to not just get at that material, but you're going to have to process that. And so all the things factored together into the overall strategy of how you use robots like VIPER, which are going early, followed by human missions that come later. And frankly, long term, maybe this is a long-term sustaining infrastructure. So we'll be going to the moon regularly to explore the moon and maybe go elsewhere.
Awesome. Thanks so much for joining the show, and we look forward to hearing more about VIPER in the future. Take care.
My pleasure. Thanks.
You're watching NASA Edge, an inside and outside look at all things NASA.
Experience. Innovation. Safety. The Aeronautics Test Program at Dryden Flight Research Center. Flight Loads Laboratory. Research Aircraft Integration Facility. Western Aeronautical Test Range. Support Aircraft. The Aeronautics Test Program at Dryden Flight Research Center. NASA Dryden's Aeronautics Test Program, Flight Operations and Test Infrastructure Project offers government agencies, corporations, and institutions an extensive range of state-of-the-art support aircraft, communication and telemetry, simulation, and structures research capabilities. NASA's Aeronautics Test Program assets located at Dryden Flight Research Center. Advancing technology and science through flight. Flight Loads Laboratory. Given its vast physical resources and highly experienced technical staff, the Flight Loads Laboratory is a unique national resource constructed to support flight research and tests of aircraft structures dating back to the X-15 Hypersonic Research Program. At NASA Dryden's Flight Loads Laboratory, a comprehensive set of structural test capabilities can be achieved, including thermal, mechanical, structural dynamic, and mass properties testing of large-scale structures performed independently or simultaneously. To support testing capabilities, the Flight Loads Laboratory utilizes both conventional and advanced instrumentation technology. The Flight Loads Laboratory utilizes a wide array of test systems, including radiant heating, hydraulic load control, a soft support system, and a variety of measurement systems to support ground and flight research. Tests conducted in the Flight Loads Laboratory utilize the most advanced structural instrumentation capabilities available, including state-of-the-art sensors and measurement systems, advanced sensor integration techniques, and systems for sensor characterization and validation. With its expert staff, distinctive capabilities, and flight line access, the Flight Loads Laboratory provides unique test solutions, all under one roof, that meet customer requirements, from subsonic through hypersonic flight. Research Aircraft Integration Facility. Another one-of-a-kind resource offered by Dryden Flight Research Center's Aeronautics Test Program is the flight simulation capability located in the Research Aircraft Integration Facility known as the RAFE. Designed to house project and facility management, vehicle maintenance, and engineering personnel, the RAFE can support a wide variety of advanced, highly integrated research aircraft through all phases of a research program, from concept to flight.
Okay, we'll drive all the way to hold and get skiff. Copy.
Among its more rare capabilities, the RAFE offers high-fidelity, real-time and batch flight simulation, closed-loop, hardware-in-the-loop, pilot-in-the-loop, and vehicle-in-the-loop verification and validation testing. The RAFE offers 11 different simulation labs with the ability to customize for specific research aircraft and unmanned vehicles. The co-location of project and facility management, vehicle maintenance, and engineering personnel allows the RAFE to support advanced aeronautical and space-based research throughout all phases of the research program within a single facility. Western Aeronautical Test Range.